All right, today we're going to talk about solving radical equations, and they're pretty easy to solve, but there are some things you're going to have to remember. If you have an even index, you cannot have that equal to a negative number. Those are going to be no solutions if you have an even index. So if you have a square root or a fourth root, and we have it set equal to a negative number, we're going to have to answer no solution. And you can see what we're going to do is in order to solve these, we're going to raise the root to the opposite of its index. So on a square root, you'll square to cancel it out. And if you square on one side, you will square on the other. And so that's how we end up with an x equal 9, because a square root squared just has the x come out, and then you have 3 squared, which would equal 9. Over here, you can see if you have a square root equal to a negative number, if you tried to work it like we worked the first one, and you square both sides, you get a positive 16. But if you go in and you try to check it, the square root of 16 does not equal negative 4. That's why you can't have the even indices equal to negative numbers. So here are our steps for solving these equations. First step, you need to isolate the radical. That means get the radical by itself. Okay, second, you're going to raise each side to a power equal to the index. Okay, then you're going to solve the resulting equation. And on these, I don't make a big deal about checking solutions, but you might want to check your solutions, because sometimes, especially if we end up with one where we have to factor and you have 2 answers, one may work and one might not work. It just depends on if we end up having to deal with the negative. So down at the bottom of the page, you can see here's another couple of examples. I've got square root of 2x plus 1 equals 5. That square root is isolated, so we can go straight to squaring both sides. So then that makes the 2x plus 1 come out, and then 5 squared is 25. And then we just have to solve for x. We subtract 1 from both sides, so you get 2x equals 24, and then divide by 2, and you get x equals 12. On the right-hand side, this one is going to have a little bit more work to it, because I have an x minus 1 that I'm going to square. So when you square 6x plus 1, the square root of it, you get 6x plus 1 to come out. But now over on the right side, you've got x minus 1 squared. Don't forget, that's the same thing as x minus 1 times x minus 1. And that's something that you're going to need to FOIL in order to get that x squared minus 2x plus 1 that's down there. Once you have gotten this one, you can't just solve for x because we have an x squared. So that's why we are going to subtract our 6x and subtract our 1 and bring everything to one side. Then it's something where you're going to have to factor. So if you end up with an x squared after you have squared both sides, you're going to need to do some factoring. Okay, let's look at the next page. You can see at the top of the next page, that's where they checked. That's where they were checking to see if their answers were correct. Okay, so let's try some examples. We've got square root of 3q minus 2 equals 2. So the square root is isolated, so I'm going to square both sides. So when I square the left side, 3q minus 2 comes out, and then on the right side, 2 squared is equal to 4. And now we're going to solve this for q. I'm going to add 2 to both sides. So 3q equals 6. I'm going to divide by 3. So q equals 2. And then you don't have to write it out, the checking, but just go back and look. 3q, so 3 times 2 would be 6. 6 minus 2 would be 4. The square root of 4 is 2, so that one checks. Okay, the next one, let's just do one. I'm going to add an example. Let's see. If we have square root of x minus 3 equals 5. Well, the square root was isolated, so I'm going to square both sides. So I get x minus 3 equals 25. Add 3 to both sides. So x equals 28. 28 minus 3 in the original problem would be 25. The square root of 25 is 5, so that one checks. Okay, if you have something that looks like this, cube root of x minus 2 equals 7. Okay, on a cube root, we have a 3 in the indices. So that means we're going to need to, first of all, make sure that the root is isolated, and it is. So then you will next raise each side to that power of the indices. So this time I'm going to cube each side. So x minus 2 comes out. 7 times 7 times 7 would be 343. And then we add 2 to both sides. So x equals 345. And so if we checked that, 345 minus 2 would be 343. If you take the cube root of 343, you get back your 7. Okay, so there's some that are fairly straightforward. Now let's look at this number 2 that I've got over here. I've got x minus 5 equals square root of 4x minus 15. Now, even though the root is on the right-hand side, the other ones we've kind of kept them on the left side, it's still isolated. It's by itself. So it's a square root, so I'm going to square both sides. Now, if you need to come over here and as scratch work, do x minus 5 times x minus 5 and FOIL it, then come over here and pause the video and go over there and do the scratch work. I'm going to go ahead and write it as x squared minus 10x plus 25, because I know that's what I would get if I FOILed it, and then equals 4x minus 15. So now, since this is a quadratic, it's a squared, I cannot just solve for x. I need to bring everything over, and then we're going to factor. So minus 4x plus 15. So x squared minus 14x plus 40 equals 0. So now to factor it, I'm going to find factors of a positive 40 that add up to 14. So a positive 40 that add up to a negative 14 would be negative 10, negative 4. So I'm going to have x is minus 10, x minus 4 equals 0. So if you set each one of those equal to 0, you're going to get x equals 10, and you're going to get x equals 4. So this is one where I would check both of the problems. If I have a 10 and I put it in my original problem, 10 minus 5 is 5. Okay, so we're going to see if whatever we get for the square root, if we get a 5. So if I come over here and I put a 10 in for the x next to the 4, I'm going to have 4 times 10, which is 40, minus 15, which is 25. Square root of 25 is 5. But watch what happens when I put the 4 in. 4 minus 5 equals a negative 1. Because I have a negative on the left side, no matter what's going on with this square root, I can't get a negative 1 on the right side. So I have to throw out the negative 4, and the x equal 10 is the only answer that I can use. So be very careful when you get two answers especially. Okay, on this next one, I have a cube root. So the first thing I notice is that cube root is not isolated. There's a 2 in front of it. So I'm going to divide both sides by 2 first. So I'm going to have cube root of 4x minus 5 equals 4. And since this is a cube root, I'm going to cube both sides. So that means 4x minus 5 equals 4 cubed is going to be 64. My pen keeps wanting to do crazy things. If I add to both sides, if I add 5 to both sides, I get 4x equals 69. Then divide by 4. So 69 over 4 will be the answer for this one. And usually if you get something that crazy, it's probably one you're not going to throw out. You'll keep it. Now look at the bottom of the page. I have the fourth root of 9x minus 15 plus 60 equals 2. That 60 needs to move because I need the root by itself. And when I subtract 60 from both sides, I get fourth root of 9x minus 15 equals a negative 58. I don't have to go any further. I have an even root equal to a negative. That means I have no solution. Okay, you don't even have to work it any further. Just go straight to no solution. Only on the even roots. If that had been a cube root, I could have worked it. Okay, so what if we have, I'm going to give you one where we're not having any, where we have double roots that are this difficult on ALEKS. So I wanted to show you this one. What if I had square root of x plus 2 equals square root of 3x minus 8? Okay, you might possibly have a square root equals a square root. Well, in this case, squaring both sides will eliminate the square root on each side. So x plus 2 equals 3x minus 8. So we're going to solve this just like we normally would. I'm going to subtract 3x from both sides. So negative 2x plus 2 equals negative 8. Subtract 2. So negative 2x equals negative 10. Divide by negative 2. So x equals 5 for this one. So that if you have a square root equals another square root, just square both sides. If that had been a cube root equals another cube root, you'd have cubed both sides. So you always raise it to whatever power is in the index. And remember, square roots always have an imaginary 2 as their index. And that's how you solve equations. Please be sure and email me if you have any questions whatsoever.